Mr. Smith here. Good morning. And we are in section 5.5, working on some homework. Technical difficulty, so you get to see me today. I hope this is good. All right, so we are doing some problems from the homework, and we're going to start off by factoring this guy. All right, so this is a fourth degree polynomial. We're not used to factoring them, but all of our rules still apply. Everything is exactly as it was. So instead of an a and an a here, right, traditionally that's what we put. It's now a squared and a squared, and that will multiply to give us a to the fourth. Both signs have got to be plus and plus. And now factors of 6, we can go with 3 and 2, which is usually where we'd want to start. But instead we're going to go with 6 and 1. Okay? And 6 and 1 because it will help us to get 7 in the middle. Okay? And remember that we use a guess and check approach. And if we check this, a squared, a to the fourth, a squared times 1 is a squared. 6 times a squared is 6a squared, so that gives us 7a squared. Front right, please. Beautiful. Much better. Okay, so that's the right answer. Next problem. So the first type of factor we always want to do is we want to see if we can common term factor. Okay, first type of factoring, common term factoring, and in this case I can pull out a 2z. If I do, that's going to give me 16z cubed minus 1. 16z cubed minus 1. And now this is a difference of cubes. This is the difference of cubes. So this is 2z, and now we just need to identify what's being cubed here minus what's being cubed here.
Would that be 16z to the 4th?
I apologize. You're absolutely right. It should be 16z to the 4th. So scratch that. This is not a difference of cubes. This is a difference of things being squared. This is a difference of things being squared. Namely, this is 4z squared minus 1 squared. And the reason I wrote it like that is so that we have this rule that says if you have a squared minus b squared, it equals a minus b, a plus b, times a plus b. All right, we've seen that before. We've just never seen it with something to the 4th degree, 4th power. All right, so in this case, we will factor this to our original first term factor, 2z, and then it will be times 4z minus 1, 4z plus 1. 4z minus 1, 4z plus 1. Okay. And that will get us to here, right? 4z times 4z is 16z, sorry. So this should be 4z squared, squared, squared. Now let's check that, right? Again, we're using a guess and check approach. So if we check this, 4z squared times 4z squared, 16z to the 4th. The middle term should drop out, right? The middle term should drop out, so that should not be an issue. And then minus 1 times plus 1 should still get us the minus 1 here. Okay? Yeah?
I don't understand how you did your third step.
We went from here to here?
No, just how you went from the second to the right there.
Right. So this is literally a squared minus b squared.
Oh, you used that. How do you know when you need to use that?
So this is actually something we've seen before. We saw this in chapter 4. right? But I was about, when I made my mistake, I was about to use this as something cubed, and then I would have used that previous formula that we've seen before in this section, right? Because I had something cubed minus something else cubed, right? So that's when you would use that formula. How did I know to do this? Because I see that I have something squared minus something else squared. I have something squared, namely 4z squared squared. I mean, this is similar if we talk about a problem that we would have seen before. You know, if I gave you 4z squared minus 1, and I just asked you to factor that. 4z squared minus 1, ask you to factor that. Right? Well, we've seen this before. It's 2z minus 1, 2z plus 1. Okay? That's the exact same idea here. It's just it's not z squared anymore. It's z to the fourth. Is that okay? Okay, cool.
How did 16z to the fourth go to 4z squared?
It didn't. 16z to the fourth went to 4z squared squared. I rewrote this as something squared. And you just have to see it. You just have to come up to a brick wall here and say, what am I supposed to do? Right? And when you enter that brick wall, now you start creating things. And I was about to try to write this as something cubed. Cubed minus cubed, that doesn't work. So it went squared minus squared. Otherwise, it's not factorable. All right, so this is a problem where we're going to use factor by grouping. All right, so we throw in our parentheses. But as I put in the second set of parentheses, I need to change that sign to not change the problem. I'm changing the problem so that I don't change the problem. And now, I'm going to factor z to the fourth out here. That leaves me z minus 3. I'm going to factor out a 16 here. And it leaves me z minus 3. At this point, I'll now factor out a z minus 3 out of both of these. Z minus 3 gets factored out of the first term. That leaves me z to the fourth. I factor out a z minus 3 out of the second term. That leaves me 16. And now again, this piece will factor farther. Z minus 3. This factors to z squared minus 4. Z squared plus 4. I think this is probably a little easier to see what I'm doing there than it was on the first problem. Well, again, this is a difference of squares. Z squared times z squared is z to the fourth. Middle term should drop out. And then minus 4 times 4 is positive 16. Negative 16. Negative 4 times positive 4. Negative 16. Okay? But we're not done yet. Because z squared minus 4 also factors. So we have to factor that. So z minus 3, z squared minus 4 factors to z minus 2, z plus 2, and then this is z squared plus 4. Okay. Z squared plus 4 does not factor any farther. Right? This piece does not factor any farther. So we're done there. It just doesn't. If the solutions are imaginary, if we were to solve this equation, we'd have imaginary solutions. That's enough for you. But this piece does not factor, but z squared minus 4 does. So we need to factor it farther. And here we have our last problem. This is 3s to the fourth minus s squared minus 24. Yes? I hope. All right, so we throw in our parentheses. I see a minus sign here. So that means we're going to have a plus sign and a minus sign. The factors of 3s to the fourth, we're going to use 3s squared and then s squared. 3s squared and s squared. Factors of 24, we should start with the middle pair, 6 and 4. 6, 4, I don't think that's going to work. 6, 4, 6 and 4, no. So 6 and 4 don't work. How about 8 and 3? That looks a little better. So when I multiply this out, 3s squared times s squared is 3s to the 4th. 3s squared times minus 3 is minus 9s squared. S squared times 8 is plus 8s squared. So that should give us minus 1s squared in the middle. And now 8 times minus 3 is minus 24. And there we are. We should look to see if anything factors farther. This could factor, except there are no, 3 is not a perfect square, so we don't factor any farther. Okay? So this concludes some of the homework problems from section 5.4. We'll now press on to 5.5. Section 5.5. So, the good news is everything we're going to do in section 5.5 is built off of basic things that you've seen before. Let me start with this. 40 equals 8 times x. What does x equal? X equals 5. The good old days, right? How did you do that? We divided. Divided 40 by 8. The only difference is now we're going to do this with polynomials. So I give you a polynomial. And I tell you that one of the factors is x plus 3. Now there's another factor, but I don't know what that is. So, how do we figure out what the other factor is? We're going to divide. So that's the underlying idea of what we're going to do here. But there's one other basic thing we need to talk about, and that is division. Okay, so how do we divide? And this is going to form the basis. This will be the understanding of everything we're going to do here. So, what do? We say, well, 34 divided by 12 is what? So, how about 2, right? That should get us pretty much there. But now I take the 2, and I multiply by the 12, and I get 24. Now what do? We subtract, right? So here we subtract. So I bring down the 12. I bring down the 10. Now I bring down a 5. I say 105 divided by 12 is what? What number should we put back up here? Go ahead. Is it 8? Now what do? We multiply, right? So 8 times 12, 96. Now we subtract. Okay? That should be 5 4s 9. What do? Bring down the 6. Should be an 8 times 12, 96. Subtract, and what's our remainder? 0. This process is exactly the same as what we're going to do, except we're going to do with polynomials. Okay. So, what we're showing here is here I have my polynomial function f. I'm going to divide it by some polynomial d, and that's going to equal q to the quotient plus r the remainder. That's the idea here. That's the idea. Okay. So here we go. So the first thing we do is we write it out using our long division notation. And And as we're doing this, notice how I'm starting with an x to the fourth. It's imperative that we not skip any values from here. Okay. So I'm at 3x to the fourth minus 5x cubed, but notice how there's no x squared term here. We need to add one. So we'll add 0x squared plus 4x minus 6. Plus 4x minus 6. And now we're going to do division. And so the first division we do is we take this piece, 3x to the fourth, and divide it by x squared. And so 3x to the fourth divided by x squared should just give us 3x squared. And that's going to be our first answer in the quotient, and it's going to go in the x squared column. X squared. It's important to keep your columns. You've got to keep columns. So 3x squared. Now what do? We multiply. So I'm going to take the 3x squared times x squared. So 3x to the fourth. 3x squared times negative 3x, negative 9x cubed. 3x squared times 5 is plus 15x squared. What's the next step in the process? We subtract. Okay, this process is identical to the one you learned in 4th grade. We subtract. So, subtraction here means that we change all of these signs. It's literally what subtraction is. Change all of the signs. And now we can combine like terms or add them. All right, so this is 0. This is plus 9x cubed minus 5x cubed is 4x cubed minus 15x squared. And now what's the next thing? We bring down 4x. Here's the good news. The process starts all over again. Great news. I know. 4x cubed. So now we do 4x cubed divided by x squared. That gives us 4x. So this is what's going to go in the x's column of the quotient. That's 4x. Now what do? We multiply back through. Okay, so we multiply the 4x times everything here. Multiply the 4x times everything there. So that's going to give us 4x times x squared is 4x cubed. 4x times minus 3x is minus 12x squared. And 4x times 5 is plus 20x. Now what do? We subtract. Subtraction means changing the signs. Minus plus minus. So 4x cubed minus 4x cubed is gone. This just is negative 3x squared minus 16x. We bring down the 6. Bring down the 6. Okay, again, 4x cubed minus 4x cubed is 0. 15x squared plus 12x squared is negative 3x squared. 4x minus 20x is minus 16x. Bring down the 6. The last division we're going to do is negative 3x squared divided by x squared. So right out here, negative 3x squared divided by x squared is just negative 3. And so that's going to go here, negative 3. You can see these problems take up a huge amount of space. So please leave a lot of space to do these problems. Now what do? We multiply. Negative 3 times x squared. Negative 3x squared. Negative 3 times negative 3x plus 9x. Negative 3 times 5. Negative 15. What do now? We subtract. So subtraction means changing the signs. Minus plus plus. Negative 3x squared, they cancel out. This leaves us with negative 25x plus 9. Negative 25x plus 9. What is this thing down here? This is the remainder. This process works exactly identical to the process we've seen before, and it repeats itself after you've done the subtraction piece. Okay. I recognize there's a lot here. Two things. We have two ways to write the remainder. We can write it as r, and then we just write this piece out. 25x plus 9. So we just write it there. It's method 1. It's probably the easier method. Method 2 is we write out plus, and then we write negative 25x plus 9, and then we write that over this guy. Divides x squared minus 3x plus 5. Those are our two options. Now, I know you have a lot of questions. Before we do, let's do one more problem. Let's get it under our belt, and then I'll try to go back and take questions. So here we go. Again, we're doing long division. This is referred to as polynomial long division. All right, so we have x minus 2. It's going to be outside. Now we're dividing x cubed plus 5x squared minus 7x plus 2. Again, as we start the problem, it's very important that we not have any gaps here. Should not have any gaps. So x cubed, x squared, x constant. Here we go. The first division we do is x cubed divided by x. That's just going to give us x squared. It's just going to give us x squared. So that's going to go in the x squared column. Now we multiply. X squared times x cubed, x squared times minus 2, minus 2x squared. Now we subtract. Subtraction means changing the signs. So x cubes cancel. 5x squared plus 2x squared is 7x squared. And I bring down the minus 7x. Now the process repeats. One thing that you need to be aware of or very careful about is when you change the signs, you need to do it some way that you know that you have changed the signs. Because when you go back to check these problems, if you can't tell whether or not you changed the signs here, you won't know if you did the problem correctly or not. Now, it's very easy for me to change colors on the board. It's not so easy for you to do that yourself. So, at this point, the process starts over. We're going to take 7x squared divided by x. That equals 7x. So this will go in the x's column. Plus 7x. Now I multiply. 7x times x is 7x squared. 7x times minus 2 is minus 14x. Now we subtract. Subtraction means to change the signs. Minus, that becomes plus. So this is 7x plus 2. This is the last division we're going to do. 7x divided by x, which equals 7. This will be the number that goes in our constant column. Okay, so you see everything lines up in columns. X squareds, x, constants. Everything should line up in columns. So we have 7, we do the multiplication. 7x times, well, 7 times x is 7x. 7 times minus 2 is minus 14. Minus 14. Now we subtract. Subtraction does this, and that gives us 16 as our remainder. And I'll write that out as 16 plus 16 over x minus 2. And this is probably my preferred way for you to write remainders at this point. I'll pause in just a moment for some questions, but before I do, I want to show you how this fits together. So here we are. Here I've given you a polynomial, and I've told you that one of the factors is x minus 3. Now, I don't know what the answers are, but let's assume for a moment that they're complex. So the other two solutions, this polynomial should have 3 solutions to the equation. Let's assume that the other 2 solutions are complex. At that point, then there's no way for you to figure out what those solutions are unless we use long division and divide out this polynomial, 2x cubed minus 11x squared, and so on, divided by x minus 3. And when you divide that, what you're going to get is a quadratic equation. It's a quadratic equation. And now we can solve the quadratic equation using the quadratic formula. What that means is that these problems now are twice as long. Not only do you have to do long division, you're also going to need to use the quadratic formula. So these problems take up a lot of space, they take up a lot of time. Right, but that's where we're going. So for today, you should go home and practice long division. There'll be a few problems on the homework that are strictly long division. You should practice those. The homework is not due tomorrow, but you should know how to long divide when you come in tomorrow. Okay, so let me stop the video now.